Hey everyone, in this video we will learn that what's on the board. I will explain you about all the elements that are on the Arduino and mainly those that we are going to use and those that play a major role in the working of Arduino. So the elements are categorized into four categories that are power elements, pins, communication elements and brain and programming. Now let's discuss these one by one. So first of all we have the power elements. As the name suggests, these are those that are responsible for the power supply and regulation. Here in this one, we have 5 elements that are USB connection that you can see on 1. Then we have the barrel jack that is on the 2 in the left bottom. Then we have the voltage input pin in the middle bottom that you can see on 3. That on 4 we have the power indicator on the top right. Then we have on 5 the voltage regulator that is above the barrel jack. Now here, first 3 are responsible for the power supply and other 2 are just indicator and regulators. Now the first method to power up the Arduino is by using the USB connection. Here as you can see in this picture, by connecting this blue cable that you will get with the Arduino, you can power up your Arduino just like this one. So here you need to plug the USB port in your computer or laptop USB port and the other one into the Arduino. Now this port is also used for programming, but we are going to discuss that in the later slides. So this is the first method to power up the Arduino. Now after this, the second method to power up the Arduino is by using barrel jack. You can use the barrel jack of your Arduino to supply voltage. You can plug a 5.5mm/2.1 mm DC barrel plug with batteries or a power adapter. You can see the DC jack here in the bottom, in which we have the positive terminal inside and negative on the outside. Also, here the recommended voltage is 9 volt to 12 volts. However, the Arduino can work up to 20 volts, but above 12 volt it will damage the Arduino. Now after this barrel jack can be used in multiple ways. And first one is with the help of an adapter. Electronics is really flexible. You can use any method to complete any task. You just need to make it solve the problem. So in the first method, we generally use 12 volt adapters. These are the adapters that you can easily get on any shop. Just ask for a 5mm DC jack 12 volt adapter. Now they are really efficient when it comes to immobile projects, but not with the moving robots because of the limited wire length. So this is the first way to use the barrel jack. Now after this, you can use barrel jack with batteries. So you can also use batteries greater than 5 volt with the help of a battery snap that you can see here. So you just need to use this snap like this one. Just connect the battery with this connector and insert the DC jack in the Arduino. And you can just simply power up your Arduino. Now after this, the third method to power up the Arduino is by using rechargeable batteries. It's the most efficient method for robots and mobile projects. However, it's a little complex one. In this, you need a rechargeable ion battery like this one in the picture that you can see. But for that, you need multiple connectors. The first one connector you can see below the battery. So this is the direct connector in which you convert the battery into DC barrel jack. But it's not simply available in the market. So you have to use these two adapters, this XT60 and XT60 male to DC, where first you convert the battery into XT60, then XT60 to DC barrel jack. So it sounds a little complex one here. Now these are the methods by which you can use the barrel jack. And after this, we have the voltage input pin. That is the third method to power up the Arduino. So you can find this pin listed as VIN. Here you can see in the middle bottom picture and on the top right picture. And you can use a battery or AA batteries, and you just need to connect the positive terminal into VIN and negative terminal in the ground. And by this you can power up your Arduino. Here the reference voltage is again 7 to 12 volts. Now after this, we have power indicator LED that you can find on the top right corner just beside the Uno. So you can see here this LED symbolized with on. Now this LED indicates that Arduino is powered up or not and is in what state. If it's not glowing, then there must be some fault in either connections or in the Arduino. So it's just to check whether your Arduino is working fine or not. And after this, we have the voltage regulator. So you can find the voltage regulator here above the barrel jack. Now the voltage regulator does exactly what it says. It controls the amount of voltage that is let into the Arduino board. Think of it as a gatekeeper. It will turn away an extra voltage that might harm this circuit. However, this has also a limit. If the voltage is increased above the 20 volt, then it will first damage the voltage regulator, then it will damage your Arduino. So it's fine if you use voltage less than 20 volts. Now these are the power elements. And after this, we have the pins that you can see on these positions 1, 2, 3, 4. Here there are basically 4 types of pins: digital pins, analog pins, power pins, and some extra pins. Now before learning about the pins, first let's understand what is digital and analog signals. Now let's consider an example. Here you can see two LEDs. First one is this one, that is just getting on and off, on and off. And here we have the second one that is getting from minimum brightness to maximum, then coming back to zero brightness. We can call it as a fading of LED. Here, the LED getting on and off is an example of digital signal. A digital signal is a signal that represents the data as a sequence of discrete values. It can only take on one value from a finite set of possible values at a given time. And you can simply understand it as it will be the yes or no. There is nothing like how much. So most of the electronics equipment work on digital signals. So you can see a digital signal like this one. So either it will be 1 or 0. Now after this, we have the analog signals. So analog signal is a continuous signal in which one time varying quantity such as voltage, pressure, etc. represents another time based variable. Also, everything around us is in analog signals. From talking to sound to energy to everything is in analog form. And also all natural signals are analog. There is no natural digital signal. And you can see an example of analog signal here. Now in analog signals, we have a large number of values. Unlike the digital signals, there we have only 2 values. We have hundreds and thousands of values. So it will be hard for the computers or any microcontroller to process hundreds of values. So we generally use the digital signals. They are easy to process while analog signals are complex, as I have told you, because of thousands of possible values. So that's why most of the sensor and devices we use work on digital signals. Now, even if I am right now talking to you, you are listening my voice. It is an analog signal because it's a continuous value. Another example is, what if I ask you, is it hot outside? Then you will say either yes or no. Then that will be a digital value. But what if I ask you how much temperature? What's the temperature outside? Then you will tell me something like 40 point something, 12 point something degree. There can be multiple values possible there. So that will be an analog value. Now here you can see the representation of analog and digital side by side. Now here I have just given you a quick overview of digital and analog signals. We will learn more about these in the sensor modules. There we will work with these. There we will understand that how digital and analog signals work. So for right now, just definitions are enough and you will understand them more in the sensors module. Now after this, let's understand the digital and analog pins. So we have 14 digital pins labeled from 0 to 13 that you can see here that I have highlighted. Now pin 0 and 1 are communication pins. We will discuss about these in the communication slides. Now few pins have a symbol like this that you can see in the third point and in front of pin number 3, 5, 6, 9, 10 and 11. It represents that pin is a pulse width modulated or a PWM pin. Now what does it simply means? That you can use that pin both as digital and as analog pin. So right now it's enough for that also. Now after that we have analog pins and we only have 6 analog pins labeled from A0 to A5. As most of the equipments process digital signals easily, so that's why we have 14 digital pins while only 6 analog pins. And we will learn more about these pins when we practically work on them. So you will understand them much better there. Now after analog pins, we have the power pins. So their function is to either provide power to the sensors and modules that we are using or to the Arduino. Here you are already familiar with the V-in pin, and rest we have 3 ground pins that work as the negative terminal of any circuit, and one 5V and one 3.3V pin. So here the 5V pin is used as a 5V output for sensors, modules and shields, etc., while 3.3 is used as a 3.3V output. So it depends on the sensors that what voltage supply do they need. Now here the G and D pins are just ground pins that are used to complete this circuit. They work as the negative terminal. Now after that we have few extra pins that you can see on both sides of the Arduino, after the ground pin on the right and after the 3.3 pin on the left. So we have 6 extra pins on our Arduino. Generally they are not used much but serve some special features. Like here we have a reset pin that is used to reset the program automatically. Then we have a IO ref pin which is used as input output reference voltage pin, and also an AREF pin on the right that is used an analog voltage reference pin. And after that we have 3 unlabeled pin, 2 on the right above the AREF. They are generally the SD and SCL pins that are used for serial data transfer, and one on the left that has no use. Now after pins we have the communication elements. Suppose if we have to make external data transfers or any communication like using Bluetooth, Wi-Fi or communicating with another microcontroller, as you can see on this picture above, then for that we have 2 separate pins, pin 0 and pin 1, labeled as RX and TX pins. So these are used for the communication purposes. TX pin is used for transferring the data while RX pin is used to receive the data. We also have 2 LED indicators, TX and RX LEDs, that you can see here highlighted on the middle top. So these are used to acknowledge the transfer of data. If we receive something, then RX LED will blink. Otherwise, if we transfer the data, then TX LED will blink. Now after the communication elements, we have brain and programming, the last elements on our Arduino. So this consists of an IC. This small black outlined element is known as an IC, or we can call it as an integrated circuit. It's the combination of various logical circuits that are designed to execute different tasks. These ICs act as the brain of particular device. Every single device has an IC brain, from a mobile to computer to even a washing machine. Every single device uses an IC, and there are different types of ICs in the market, depends on the functions required and on the device. The one that Arduino uses is known as ATmega38PPU, that you can see written on the top of that IC. Now after that we have programming an Arduino. So there are basically 2 ways to program the Arduino. First one is by using the USB port that I have also told you earlier, that we can use this port also for programming purposes and with the help of that cable and the computer. Now second method to program the Arduino is by using ICSP pins and USB uploader. You can see the pair of these 6 pins on 2 different locations on the Arduino that I have highlighted here. Now these can also be used to program the Arduino. You will just need a USB uploader like this one. So what's special about this method? So here by using these pins you can program the Arduino as well as you can program the ATmega IC. Now after this we have a reset button. So if you want to reset your code, then you can manually do it by pressing the reset button on Arduino. It will run the code again from the start. So this is about this video. If you still have any doubts regarding any element on the Arduino, you can ask me in the questions and I will be very happy to help you out. So thanks for watching, and I will see you in the next video.